Dear students, for complete oxidation of 1 molecular glucose during aerobic respiration, there are 10 NADH and 2 FADH are formed. And out of 10 NADH, 2 NADH, 4 ATPs by substrate level phosphorylation, and 2 NADH by oxidation of glycolysis are formed. And this glycolysis is occurred in the cytoplasm, or you can say cytosol. 2 NADH and 2 CO2s are formed during link reaction in the matrix of mitochondria, that is nothing but inner compartment. So during this time, which product is formed? So we know already 2 moles of acetyl coenzyme formed, and these 2 moles of acetyl coenzyme is a link substrate between glycolysis and Krebs cycle. And 6 NADH, 2 FADH, 2 ATPs, and these 2 ATPs are formed by substrate level phosphorylation, and 4 CO2s are formed in this Krebs cycle. So why this NADH and FADH are formed? Because of their oxidation in electron transport system, they can form the ATP. So for example, in the electron transport system, one NADH oxidation, so during this time one oxygen atom is involved, one H2 is formed, 3 ATPs are formed. So therefore, for 10 NADH and into 3 ATPs H2O, one oxygen atom, that is equal to 30 ATP, 12 10 H2O, 10 oxygen atoms. For 1 FADH2 oxidation, one oxygen atom is involved, one H2 is formed, 2 ATPs are formed. So therefore, for 2 FADH, and there you can find 2 FADH2 into 2 ATP, 1 oxygen atom, 1 H2O, that is equal to 4 ATP, 2 H2Os, 2 oxygen atoms are involved or formed. Overall 34 ATPs, 12 H2O, 12 oxygen atoms, that is equal to 6 oxygen molecules are formed in the ETS. In this ETS, we can understand what is the first reaction. The first reaction is oxidation and the last reaction is reduction. How? How you see this? And during this oxidation of NADH, there what is the electron transport? Here NADH is oxidized to NAD plus. Why NAD plus is formed? Because this NAD plus again is involved in the recycling process to form the NADH. And during this NADH releasing two electrons, which are transported to complex 1 to ubiquinone, complex 3, cytochrome C, complex 4, finally oxygen atom. So this oxygen atom is receiving two electrons from these complexes and also two protons from the matrix. As a result, one H2 is formed. So at this moment, four protons are transported from matrix to intermembrane space at complex 1, and 4 protons at the complex 3, and 4 protons are displaced at complex 4, but out of 4, 2 are transported to intermembrane space, 2 are transported to oxygen atom. If FADH is oxidized, the electron transport is like this: complex 2 ubiquinone, complex 3 cytochrome C, complex 4, and finally reach to oxygen atom. So at this moment, the complex 1 is not involved. When NADH is oxidized, complex 2 is not involved. As it is here, which are the common for the NADH, FADH, we know that ubiquinone, complex 3, cytochrome C, complex 4, and oxygen atom. But complex Y is not involved. Why? Complex Y is an ATP synthase. So when protons are moving from matrix to intermembrane space, because of the proton concentration gradient, the protons are again moving from the intermembrane space to matrix with the help of complex Y. As a result, ATPs are formed. Here, during this oxidative phosphorylation, which are electron transporters, which are proton transporters, by seeing